Hi there. Today I want to talk a little bit about permutations. Permutations are used in a lot of different math classes. My specific class is Saxon Course 2, and it happens to be one of the problem-solving questions. But I decided that it would be good to have just a short video talking about permutations so that people have a better idea of really what they're used for and how to compute them without stressing out, because it's not that difficult. Let's say we want to do a permutation with 3 colors of Skittles, and let's say we have red, green, and orange Skittles. How many combinations or permutations can be created from these 3 colors? Now, it's important to realize that order is important. The order the Skittles are in makes a big difference. Okay? So let's just start with the red Skittle. If we put the red Skittle in the first position, we can have green in second and orange in third. If we put the red Skittle in the first position, we can also have orange in second and green in third. And if you look over here, that's kind of listed right there on the right hand side. So we have 2 combinations with red in first place. Now, also, you could put green. You could put green in first place and have green and then red in second and orange in third, or green in first, orange second, red third. And here are the combinations there. So far we have 4 combinations. Last but not least, we could put orange first and then have red and green, or orange, green, and red. That makes 6 combinations. 6 different combinations, and the order is important. That's called permutation. Order is important. Now, one of the things I want to talk about is the way to figure out how many combinations there are when you only know the number of items and you know that it's a permutation, so you know that order is important. So in this case, we had 3 items, okay? And we were going to combine them using the philosophy of permutation, knowing that order had to be important. So we started with red, and then we did green, orange. We started with red, orange, green, and then we went to green, red, orange, and we went to green, orange, red, and so on and so on and so on. To do that, we use something called factorial. Okay? And to get the total number of combinations, which we've already listed are 6, okay, we would write this as 3 with a little exclamation mark right there. That's 3 factorial. Now, what do you do with that? Well, you do this. You take 3, because that's the number of items there are, and then you count down. Then you take 2 and 1. You multiply 3 times 2, which is 6, times 1. 6 times 1 is 6. And guess what? That was the answer, wasn't it? So if we have 3 different items, it can be 3 colors, 3 chairs, 3 dogs, 3 cars, whatever you want to arrange in different arrangements with order being important, and you want all the arrangements possible, you take the total number of items, and then I call it counting down, but you use factorial, and so 3 times 2 times 1. If there were 4 items, it would be 4 times 3 times 2 times 1. 5 items would be 5 times 4 times 3 times 2 times 1. It gets to be a pretty big number after a while. And there is actually a button on a scientific calculator to compute factorial, believe it or not. Okay, now, you can imagine that guidance counselors, people who are trying to figure out schedules, have to deal with this a lot, okay? So let's just take a little glimpse into a guidance counselor's world, okay? In Jim's morning schedule, he has health, math, science, and English, although not necessarily in that order. If each class is offered every period, periods 1 through 4, what are the possible permutations or arrangements of the data, arrangements of the classes, are possible, remembering that order is important? Well, we have to remember we have health, we have math, we have science, we have English. So there are 4 classes. So if we start with health, then we could have math next, right? And then we could have science, and then we could have English. But we could also start with health, and we could have English next, and then science, and then math, etc., etc., etc. We just keep going on and on. It gets kind of confusing after a while. So I'd like to show you a way to write this so that it's a little bit less confusing. Okay? And it's amazing how big it gets. Okay? So I'm gonna put it on here. I'm gonna open this up just a little bit so that you can see. Okay? So we're starting with health first. Okay? And I'm going to try to make this a little bit darker so that you can see it. Whoops, I think I went the wrong way. There you go. Okay. Whoops, that's a little too dark. Awesome. Right there. That's pretty good. Okay. We start with health, then we have math. Now, with health and math, you could have science and English. With health and math, you could have English and science. Health, you could have science and then math and English, or science and English and math. Or with health first, you could have second period English, third math, fourth science, or first, second, third, fourth. Already you have 6 possible combinations with just health being your first one. Interesting, huh? Okay, now what happens if we put math first? Well, same sort of scenario. You have math, then you could have science, English and health, math, science, health and English, math, English, health, science, math, English, science, health, math, health, science, English, math, health, science, English, science, and then science, English. Another 6 combinations. That makes 12. When you move it down, then you have science first, and you do those combinations, and that gives you another 6. And then you start with English, and you do the same thing, and you get another 6. That's 24 combinations that you could possibly get with 4 different classes, with order being important. But guess what? We already know how to get that number without even writing them. If we have 4 classes, health, math, science, and English, we can use 4 factorial, which is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is still 24. 24 combinations or permutations. That is a pretty cool thing and pretty easy to do. If you're just looking for the number of combinations, you can use the factorial. If you're looking for writing all the combinations, then you want to use something that looks like this. This tree graph is pretty good. Thanks a lot for listening to me today. I hope it was helpful. Have a great day.